All right, so in this first video, we're going to talk about some new notation that we have to incorporate now regarding derivatives. So what we know is that if f of x is equal to x squared, then the derivative is noted f prime of x with that little apostrophe. And that comes from Sir Isaac Newton. Newton, who gets credit for discovering calculus, came up with this notation right here, f prime of x, which we've been using quite extensively. But little did you know that there was another mathematician, Gottfried Leibniz, who was discovering calculus at exactly the same time that Newton was. And as the story goes, oddly enough, it was during a pandemic that these two mathematicians were locked inside of their homes, and so they kept their brains active by creating this, what we now know as calculus. Neither one of them knew they were doing it at the same time, but they were. So Leibniz, as he's discovering calculus and the concept of a derivative, he uses this notation here, dy dx. We mentioned that a while ago very, very briefly, but we really haven't used it. So we say dy dx. Now, what Leibniz, his motivation for this was, since a derivative is an instantaneous rate of change, which comes from the slope of the secant line, as we let h get smaller and smaller, that slope is delta y over delta x, the change in y over change in x. So the d here represents delta. That's why he said dy dx. So using this Leibniz notation, if we have this function y equals x squared, or it's not even in function notation, it's just y equals x squared, then we can say dy dx, the derivative of y with respect to x, is equal to 2x. Additionally, Leibniz says we can use this notation, d dx, with some argument here, which says take the derivative of that argument, of that quantity, with respect to x. So here's what this looks like. If I have something written in this notation here, the way I would read it is I would say the derivative of q squared with respect to q is equal to 2q. All right, it's the same exact concept of a derivative, it's just different notation. The derivative of q squared with respect to 2 is equal to 2q. If I have it in function notation, f of z equals z squared, then I can say f prime of z is 2z. That's Newton's notation. Leibniz would say y equals t squared, not written in function form, y equals t squared, we would say dy dt, the derivative of y with respect to t, is equal to 2t. Both of these mean the exact same thing. One is the way Newton did it, the other one is the way that Leibniz did it. Now, the second derivative in Leibniz notation, we know that the second derivative, f double prime of z, that's Newton notation. Leibniz would say a second derivative is the derivative of the derivative, df dz, with respect to z, which is then going to be equivalent to d squared f over dz squared. Now this is where it gets a little bit goofy. Why does he put d squared f, which is my numerator, over dz squared? I don't know. But that's the way he wrote it, and that's the way we use it. Now, if anybody wants to research that and figure out why that is, I'd be all ears. I haven't done its due diligence to research that, but this would be something good to research. Okay, we're going to stop there for now.